Hello again, Rustaceans. Welcome back. In this final video, we're going to do something very comforting. We're going to run the code. Specifically, we'll test the Coffee Rust calculation library locally on your own machine. The one Codcel generated from that Excel spreadsheet. Yes, that Excel spreadsheet. The one that somehow survived every rewrite attempt, every framework migration, and at least one, let's just move this logic into the app meeting. In the previous video, we added our coffee spreadsheet to Codcel, clicked Generate Project, saw that the Codcel Rust calculation library was automatically selected, and pressed Generate. And just like that, seconds later, Codcel produced a full Rust calculation project. Source code, tests, no code generation rituals required. Before we run anything, let's quickly remind ourselves how closely this Rust code matches the original Excel file. Open the hamburger menu again and select Codcel Rust Model Library. We'll go straight to Source Code. Open model cost.rust. Click Full Screen. Here we see two structs, cost input and cost output. So where are the calculations? For very sensible reasons, including separation of concerns and not making Rustaceans twitch, the calculations live in their own Rust module. Before we go further, let's look at the project structure. Click Open. Let's go one folder up. Here we have three folders. Coffee Model, where our input and output models live. Coffee Calculation, where the calculation logic lives. And Tables, which we can safely ignore here because this example has no tables. In a larger spreadsheet, this is exactly where your read-only lookup tables would live. Two separate Rust projects. Clean, predictable, no surprise coupling. Now let's go back to Codcel and run the tests. Open the hamburger menu again, select Codcel Rust calculation library, and go straight to source code. Open the cargo file. As you can see, the coffee model crate is included automatically. We also see some old friends you've undoubtedly met before, Tokyo and Once Cell. And then there's the Codcel calculation engine, which is fully open source on GitHub. Yes, full source code. This does mean you'll need Git installed to compile the project. But let's be honest, if you're watching this video, you already do. Now open source. And select codcelcost.rust. Click full screen. This file is the entry point to our coffee calculation API. We only have one calculation, cost, which, if you remember, is the output value from our Excel spreadsheet. But you'll notice we actually generate two functions, Codcel cost, synchronous, async Codcel cost, asynchronous, same logic, same results, different execution models, because sometimes you just want a value, and sometimes you want a value without blocking the universe. Both functions take a cost input and return a cost output. Let's look at async Codcel cost. First, we convert the input struct into an internal input representation. We'll ignore that for just a moment. We'll come back to it shortly. Then we call calc cost and return the result. Simple, predictable, no hidden side effects. Below this, Codcel has generated two tests, one synchronous and one asynchronous. Do they test the same thing? Yes. Is it slightly unnecessary? Also yes. But this is Rust, and tests were going to be written, whether you asked for them or not. Let's look at test cost. We call Codcel cost, with tip set to none, because in Excel, the tip had a default value of 0. Exactly as specified, we set the emergency coffee price to £2.92, and then we assert that the final cost is £3.50. Using the exact same values from the Excel file, this is important. It means we can directly verify that the generated Rust code produces the same result as Excel. No reinterpretation, no close enough. Exact match. Let's run the tests. Click the Build tab, click View Test Commands. As expected, the command is cargo test. You already knew that. Click Test in Terminal. Let's wait a moment while Rust does what Rust does. And there it is, 2 tests passed, exactly as it should be. Now, if you're really interested in how this code works internally, let's go a little deeper. For this part, we'll leave the Codcel app and use a proper IDE. My personal choice is Rust Rover. Click Source Code, then Copy Path. Open your favorite IDE and load the project from that path. Before we begin, a quick reminder. If you were writing this code by hand for such a tiny example, you would absolutely structure it differently. And you should. But remember, this code is generated. And for a large, complex Excel spreadsheet, the obvious way to write it is much less obvious. What matters is that the code is readable, the code is traceable, and the mapping to Excel is exact. Let's open the codcelcost.rust file here and go straight to the function async codcel cost. Take a moment to look at this. At first glance, this function is almost suspiciously calm. No lifetimes arguing with each other, just two very polite lines of Rust. The first line calls initialize input values. This is where our strongly typed Rust input is converted into something that can safely represent Excel. Let's open that function and slow things down a little. Here we instantiate an input struct with the name cost input. Let's pause here and actually look at what input is. Input contains two things. First, a name. In this case, cost input. Second, a hash map. This map stores the name of each input field as a string and a value enum, representing the actual Excel value. Let's open value. Value is an enum containing all the different types Excel values might become. For example, F64 for floating point numbers, integers, strings, and others. Now, this might look a little strange if you're used to Rust's strict typing. So why do we need this? Because Excel is emotionally typed. Excel is not strongly typed like Rust. To represent Excel's very flexible and sometimes very optimistic type system in Rust, we need an enum. Think of Excel a bit like JavaScript. Everything looks like a number, until it very suddenly isn't. The generated Codcel code always tries to convert Excel values into the most appropriate Rust type for the calculation, but it has to survive whatever the spreadsheet throws at it. Let's go back to the input struct. You'll see helper functions here, like add string, that make it easier to add values into the map. Both input and value come from the Codcel calculation engine, which is fully open source on GitHub at Codcel.io. Nothing hidden, nothing locked away. You can inspect every line and argue with it at your leisure. Now let's go back to initialize input values. Take a moment to look at this line. We add tip to the input. In Excel, tip had a default value of 0.0, and you can see that logic exactly reflected here. If tip is none, we insert 0.0, no guessing, no magic, just Rust. Being extremely explicit, the next line adds emergency coffee. This value must be present. There is no default in Excel, so there is no option here. And Rust's type system enforces that for us. If this value is missing, the code simply won't compile, which is exactly the kind of drama we enjoy. Finally, we return the input. Let's go back to async Codcel cost. The next line calls calc cost, passing in the input we just constructed. This is where the actual calculation happens. Let's open it. Here we build a cost output struct. And for the cost field, we call a function named sheet1 d6 round 4. That name should already feel familiar. Sheet1, the worksheet name, d6, the output cell, round, the Excel function. We can safely ignore the trailing number 4 for now. Let's pause and look at the Excel file. The formula in cell d6. Now look back at the Rust code. If you read the comment above the function, you'll see the exact same formula, preserved verbatim. This is incredibly useful. You always know which Excel cell produced this function, which formula it came from, and where to look when debugging. No archaeology required. Let's dig into sheet 1, d6 round. The function we call here is round, exactly like the Excel function. The second parameter is the number of decimal places. In Excel, that's the literal 2. Here it's stored as a constant. If we jump to the constants, we can see I32_1 equals 2. Boring, predictable, perfect. We can safely ignore the formatting parameter for now. Now let's briefly look at the Rust implementation of round inside the open source calculation engine. We won't stay here long, just enough to admire it. The function extracts the values, converts them to F64 and I32, and calls Codcel round to perform the actual rounding. Let's go to Codcel round. And yes, if you believe you can write a faster or more elegant rounding function, we would genuinely love your pull request. The community will thank you. Possibly quietly. Let's go back to the calculation file. Now that we understand round, let's look at sheet 1. D6. Add. Same sheet, same cell, same formula. As you may have guessed, this implements the addition. Look at the parameters. The second parameter retrieves emergency coffee from cell D2, exactly as shown in Excel. The first parameter calls another sheet 1, D6. Add function. This represents the left-hand side of the formula. Let's open it. Here we retrieve tip from cell D4. Again, this matches the Excel formula exactly. On the right-hand side, we see sheet 1, D6, multiply. Yes, this does the multiplication. Let's jump into it. We now see the multiplication of emergency coffee by the tax constant. The tax value lives in F64.1, which is simply 0.2. That's our 20% tax. And that's it. That entire Excel formula is now fully implemented in Rust, step by step, function by function, cell by cell. I hope you can see how closely this code follows the spreadsheet, which makes it understandable, maintainable, auditable. And now we also get all the benefits of Rust: strong typing, testability, performance, safe concurrency, and no surprise runtime behavior. At this point, you've earned yourself a calm, well-deserved latte. There's a lot more to explore. Visit us anytime at codcel.io. Thanks for watching, and keep writing Rust while Codcel handles the spreadsheets.